Hello. So I remember I promised you guys that we would have a video over solving equations. So here it is. We have x minus 4 equals 7. And x minus 4 is what we call x minus 4 equals 7 is a one-step equation. And that's because it's only going to take us one step to get our variable by itself. So I have x minus 4 equals 7. And my goal is to get the x by itself. So this is where we utilize our inverse operations of the addition property. Since I am subtracting, in order to get x by itself, I'm going to move my constant here by adding. And we talked about an equation means that we want to keep the scales balanced. So if I add 4 to one side, then I have to add 4 to the other side. So I get x equals 11. And I'm like, okay, I think I did that right. So then I can check it. So that means I can take 11 and plug into my original equation. So I have 11 minus 4 equals 7. So I get 7 equals 7, and that's a true statement. Okay, so that's our one-step equation. Now, when I look at this one, this is kind of a two-step equation because I have to make sure both sides of my equation, both expressions, are simplified. Because I can combine like terms, that means I need to do that before I do anything. So I have y minus 1.2, 1 and 2/10, apologize, equals negative 9 and 8/10. Okay, so now that I've simplified, I'm now back to a one-step problem because it's only going to take me one step to get my y by itself. So I'm going to add 1 and 2/10 because I'm subtracting it initially. That constant is initially being subtracted. What I do to one side, I'm going to do to the other side. Please bear with me in this writing. And so when I do that, I end up with subtraction. Remember, if we discussed that if I have two numbers that are opposite signs and they're being combined, that means that I'm subtracting those two numbers and taking the sign of the quote-unquote larger number. So when I'm subtracting this, I end up with 8 and 6/10. And because my 9 and 8/10, which was negative, is larger, then my final answer will be negative. And again, I can always check and go from there. Okay. On the fraction one, we're going to solve two ways. So the first way we're going to solve is by us getting rid of the fraction. So that's way number one. So first way is getting rid of the fraction. So the step here changes up a little bit. So I want to ask myself, what is the least common multiple between 2 and 4? So I'm looking at the 2 and 4. So what is the least common multiple between 2 and 4 is what I'm going to ask myself. And so the least common multiple leads me to 4. Agree? Agreed. So the least common multiple between 2 and 4 is 4. The reason why this is important because I'm going to use this to help get rid of my fractions. So in previous math classes, you learned that a fraction problem is just basically a division problem. And the opposite of division is to multiply. So notice here how we are dividing by 2. Well, we have 1/2. That means we are dividing by 2. Notice here how we have 3/4. That means we're taking 3 and dividing it by 4. So, and since the opposite of division, as we talked about, the inverse operation is multiplication. So, when I look at this problem, I'm like, okay, how can I, if I'm not good with fractions, how can I make this go away? Well, if I take both, take 4 and multiply by each term. Remember, this is a term, 1/2 is a term, x is a term, negative 3/4 is a term. Okay, and I multiply each term by 4. So I'm going to do 4 times 1/2 equals 4 times x minus 4 times 3/4. Okay, what this does is it turns it into, it takes the fraction and finds a way to basically manipulate it. I'm keeping my equation balanced because I'm doing what I do to one side, I'm doing to the other, and so I'm not affecting the outcome. So 4 times 1/2. So if I have 4 and I'm splitting it in half, that means I'm left with 2. 4 times x is just 4x. And then if I have 4 times 3/4. Okay. So a way to look at this is that essentially you have 4 over 1. And if I have the same number in the numerator as I do in the denominator, they disappear because 4 divided by 4 is 1. And all I'm left with is the 3. And now it just becomes a regular equation. So if I am subtracting 3, I'm going to add 3. What I do to one side, I do to the other. And I have 5 equals 4x. Okay? And then my last step is to divide by my coefficient. My coefficient is 4. So therefore I get x equals 5 divided by 4. Okay? So that's option 1. Option 2 is to work it just like any other equation without worrying about eliminating the fraction aspect of it. So if I have 1/2 equals x minus 3/4, I'm going to add 3/4 because it's already being subtracted, and the opposite of being subtracted is to add. Okay, so there's a couple ways to think about here. You can think about it in terms of quarters because it's 4 and 2. So if I have half, that means I have 50 cents, right? So if I have 50 cents and then I get 75 more cents, how much more money do I have? So I would have $1.25 now, right? So this gives me 1.25 equals x. Now the problem is, what if on your homework assignment it says to put in lowest fraction? So this isn't a fraction. This is a decimal. So if I'm going to think about this as a fraction, it's saying I have 1 and 1/4. And we talked about in previous math classes how if I have two numbers that are being added together, they have to have a common denominator. So this guy right here, we're going to kind of cheat and make it into a fraction because anything divided by itself is 1. So if I have 1 over 1, what would be the least common multiple between 1 and 4? Well, that would be 4. So I can multiply the top and the bottom by 4 because with fractions, you have to maintain the balance. So that gives me now 4 over 4 plus 1 over 4, which equals 5 over 4. Okay, so therefore this is equivalent to that. So 1 25/100 is equivalent to 5/4. So the next, now again, step 1 is always to simplify both sides, meaning that if you have like terms, combine them. If you have parentheses, get rid of them. So if we look at our left side and our right side, there's an opportunity to combine them. So right here, I have 6x and I have negative 5x. So if I'm combining 6x and negative 5x, that's going to make 1x. Agreed? Agreed. This pen that I'm writing with is not my friend. It does not want to write very well. Okay? On my right side, I also could combine these two guys. And 8 minus 3 equals 5. I promise I'm writing. If you have a trick to make my pen my friend, let me know. So I have 1x plus 8 equals 5. So from this problem, I can now tell myself, oh, all right, now it's just a one-step equation. So with one-step equation, my goal is to get my x by itself. And I can do that in one step because it's already 1x. So if I have a positive 8, then I'm going to subtract 8. What do I do to one side? I'm going to do to the other. So I have x equals 5 minus 8. And 5 minus 8, again, they are opposite signs being combined. So you're automatically subtracting. So that means I'm going to think 8 minus 5 is 3. My 8 is, quote unquote, my larger number, so it makes it a negative 3. Okay? Here's an example of needing to simplify because I have parentheses. So in order to get rid of my parentheses, I need to distribute. So I have 3 times 3x is 9x. 3 times negative 5 is negative 15. And again, it's not me, it's this pen that I'm working with. And so now, step 1 is done. Step 2 is I want to make sure my variables that are alike are on the same side. So notice here, my variables that are alike are 9x and 10x. And I like to avoid negatives. So what I encourage my students to do is to move your smallest variable. And it just helps you remember, what is the rule? Move my smallest variable, okay? So my smallest variable here is I have 9x and 10x. So my smallest variable is going to be 9x. So when I move 9x, I'm going to move it through subtraction because it's already positive. So I'm going to subtract 9x. What I do to one side, I'm going to do to the other. And that leaves me with negative 15 equals 1x. Okay, so what I did is if I had moved the 10, I would have had to divide by negative 1, which saved me some time. Here, I just have to use, I can rewrite it, and I get x equals negative 15. Okay, both are equivalent statements. This is just a little more proper. Okay, next, let's get a little bigger. So again, we're focusing on simplifying both sides before we start moving things across the equal sign. So here I have 4p and negative 1p. Notice that 1 is always invisible. It's like Harry Potter. It has an invisibility cloak. Puts it on, takes it off whenever it wants. So I have 4p minus 1p, which makes it 3p. I have negative 11, who doesn't have a friend to combine with. Oh, excuse me. Not sure what I just did there. Well, my computer and I disagreed on us working that problem together, so why don't you give it a try on your own? And if you have any questions, let me know. So our next problem we're going to go to is working with fractions. And the key topic for this moment is going to be the word reciprocal. Now I'm going to try to write it as nice as possible. Reciprocal. Okay, and a reciprocal is basically you're taking a fraction and you're flipping it. And what that does is that a reciprocal times its original fraction is going to equal 1. So for example, our problem has 3 fifths, right? And so the reciprocal of 3/5 would be 5/3. And what happens is when I multiply these two together, I'm going to get 15 divided by 15, and anything divided by itself is 1. So that is our purpose of reciprocal, is to help us get to 1. Now, As long as I multiply both sides by the reciprocal, then my equation is staying balanced. So here we have 3/5 A equals 12. So I'm going to multiply by my reciprocal, and I have 5 over a weird looking 3 that's going to show up, 5/3. And what I do to one side, I'm going to do to the other side. I like to turn this into a fraction if it's about to get a fraction. Okay, and my 5s, notice how they disappear. That invisibility cloak of 1 comes out. So I get A equals, and I multiply straight across. 12 times 5 is 60. That's a horrible 6. And 1 times 3 is 3. And I can simplify that. So what is 60 divided by 3, you ask? That is 20. So my answer would be 20. Okay. If you're a person who likes to reduce before working, you could have also reduced 12 and 3. If I have 12 and 3, I can reduce because 12 divides evenly into 3, and this would become 4, and this would become 1, and I would lead straight into the 4 times 5, which is 20, which is what we ended up at. It's just kind of a personal preference on how you choose to work the problem. Okay. So then next we have negative 4x equals 16. So this is a one-step problem. Okay, I'm going to do the opposite of what's happening. So if my operation is multiplication, my inverse is division. What I do to one side, I'm going to do to the other. So I get x equals negative 4. And remember we talked about the tic-tac-toe box. So for the rules for multiplication, this is so annoying. I gotta figure out a new pen. For the rules for multiplication and division, we've discussed the tic-tac-toe box. Remember, everyone wants to win when they play tic-tac-toe. So we're going to play tic-tac-toe minuses and plus signs. So again, a positive times a positive is going to obviously be a positive. Now, if I have everything else, it's going to be a negative. Okay? Because you won tic-tac-toe. There's no other way for anyone else to win because you are the winner. So what this helps you remember, if I am multiplying by a negative, so if I'm not a negative, if I'm multiplying by a positive times a negative, the answer is going to be a negative. If I'm doing a negative times a positive, the answer is going to also be a negative. If I'm multiplying by a negative times a negative, is going to be a positive. And these rules apply to division also. So I had a positive divided by a negative. So a positive divided by a negative is going to produce a negative. Okay, and then again I could check my answer. So I would plug in, and I get negative 4 times negative 4 equals 16. And we just discussed that if I have a negative times a negative, so a negative times a negative makes a positive. So therefore, my answer is correct. You're a genius. Okay, here, I'll leave you to practice this one on your own. Wait, I'm not. I'm sorry, something's in my eye. I'm going to do this one with you. So here we have decimals. Again, non-integer numbers just are not y'all's friends, but that's okay. So again, one-step problem. I'm going to divide because my current operation is multiplication. And what I do to one side, I'm going to do to the other. So I'm going to divide by negative 1 2/10. And I'm left with x equals negative 36. Trying to see if that helps. negative 36 divided by negative 1 and 2/10. Well, first off, we know that it's a negative divided by negative, which means that this is going to become a positive answer. That's step one. Another thing is a little shortcut is with decimals, you can manipulate them by multiplying by 10. And so when I multiply by 10, if I'm going to multiply my decimal by 10, what that does is it moves the decimal place one time to the right. Okay? But if I'm going to move this decimal place one time to the right, I have to move this invisible decimal place, this guy right there, one time to the right also, which now leaves room for a 0. So now the problem is asking, what's 360 divided by 12? And that's going to give me 30. Okay? So you can do decimals without stressing about it, okay? Next, OMG. I have 1/7 x equals 5/9. Go back to our reciprocal rule. So the reciprocal of 1/7 would be 7 over 1. And I'm going to multiply that by 1/7 x. What I do to one side, I have to do to the other. So I'm going to have 5 over 9 times 7 over 1. This is going to become invisible. It's going to put on its invisibility cloak. And I get x equals 5 times 7 is 35. 9 times 1 is 9. So my answer is 35/9. Okay? So the latter part of your homework assignment is combining your addition and multiplication properties. So here I have 4x minus 8x. So I'm going to simplify that, and I get negative 4x. And doesn't it now just look like another problem we've already done? OMG. I'll leave you to think about that. Here, I have 3c minus 1 equals 26. So 3c minus 1 equals 26. So I need to get my variable by itself. If I have minus 1, it's going to become plus 1. What I do to one side, I do to the other side. And that gives me 3z equals 27. Z's almost free. It's almost happy. So I'm going to divide by my coefficient. And that gives me z equals 9. A very big 9. Okay? Next, again, you're going to combine all of your like terms before you do anything. So I have 12x combined with 8x, which is going to make 20x. And then I'm going to have 30 combined with negative 6, which makes 24, positive 24. And it's still going to equal 10. Okay? And now it just becomes a two-step problem. So I'm going to subtract my constant. What I do to one side, I'm going to do to the other side. And I get 20x equals negative 14 because I have opposite signs that are being combined, which means think I'm automatically subtracting and then taking the sign of the quote-unquote big number. Okay? And then my final step here, if I'm multiplying, then I'm going to divide. What I do to one side, I do to the other. So I get x equals, I look at this and like, negative 14 and 20. They're kind of, both positive, even, not positive, even numbers. Which means that they both could be divided by 2. So I can simplify this even more. Negative 14 divided by 2 is negative 7. And 20 divided by 2 is 10. This is your perfect answer. All right, another problem where we would distribute. So I have 5. Remember I call this the Oprah property? You get a 5, you get a 5, okay? So 5 times 2x is 10x. 5 times 3 is 15. I'm trying to make it a 15. And I'm going to combine these two because they are like terms. So negative 1 plus 7. Again, opposite signs means I'm subtracting. So 7 minus 1 is going to make 6. And my 7 is the bigger number. So it stays positive. And now I'll just go through the same steps. Remove my constant away from my variable. I get 10x equals, I'm subtracting. 15 minus 6 is 9. However, my 15 was larger, so it's a negative 9. I'm multiplying, and the opposite of multiplication is division. So now I get x equals negative 9 divided by 10. Okay? Then last is our word phrases. And on the word phrases, we're going to go more detailed into this in class, but just reading some of the words. So it says, if x is the first two consecutive integers, express the sum of two integers in terms of x. Okay, so when I read that, consecutive means one after the other. So I have one number here and one number here. Okay, and so there's two ways to think about this. So my first number could be where I start from. So if I start from here, then the next number would have to be that unknown plus 1, right? It's still going to be consecutive. That means that if I was at 2, 2 plus 1 is going to make it 3. The other way of looking at it is that I, instead of starting at the smaller number, I start at the larger number. And if I start at the larger number, then it would be x minus 1, right? Now, me personally, if I can avoid having a negative, I avoid it. So it says express the sum of the two integers in terms of x. So the sum means that I want to add these two numbers together. So I'm adding this number and this number together. So I just have x plus 1, right? And what will that do? Well, I clean it up. So I have x plus 1, and that's going to give me 2x plus 1 would be the sum of it. Now notice if I do the other end where my two consecutive numbers, I start with my big number and then I work my way to my smaller number, I'm going to end up a little different. So I would have x minus 1 plus x. Combine my like terms, so x and x would make 2x minus 1. Okay? These are both acceptable answers. It just depends on how you initially wrote your consecutive numbers. I strongly suggest to stick with writing it as so, keeping yourself as in the positive zone as possible. But you know, some of you are out there like little rebels and they want to go with the negative. Next, it says, if x is the first two consecutive odd integers, express the sum of the two integers in terms of x. Now, let's think about odd integers. So I'm going to write out a couple of numbers. So if I have 1, 2, 3, 4, 5, 6, and so on and so forth, right? When do I hit odd integers? Well, hopefully you guys say every other number, right? So if I'm going to hit an odd integer every other number, how can I write this in terms of two numbers? So I want to make sure that my numbers are first a small odd followed by its consecutively larger odd. How can I guarantee that that will happen every single time? Good question. Well, I know that an odd number is always going to be one less than an even number. And I know that all even numbers are what? And multiples of 2. So when I think about that, if I wanted to somehow make 1 using the number 2, it would have to come from, let's say I did 2x minus 1. So this is saying that any number that I plug in is going to produce an odd number. So let's test it out. So if I plug in 0, for example, okay, that produces a -1. All right. If I plug in 1, that produces, I'm sorry, ignore that equals. Let me erase that real quick. It won't let me erase. There we go. -1, that produces 0. 0 is neither odd or even. It's that little floater. If I plug in 2 times 2 minus 1, that's going to make, alright, that makes a 3. What if I do, so that could work. Now, in the same token, could I also do, something is really in my eye, I'm sorry. In the same token, could I do 2x plus 1 and still get the same results? So I would have 2x plus 1, and will I get the same results? Well, let's see. I have 2 times 0 plus 1. Ooh, that gives me 1. Okay. I have, 2 times 1 plus 1. That's 2 plus 1 is 3. Ooh, that works. We have 2 times 2 plus 1 equals, oh, look at that, 5. Now, so when I look at this, if I start off with 2x plus 1, then I'm avoiding those negatives that I don't like. So I'm like, ooh, let's make that a 2x plus 1. So if I do 2x plus 1, it's going to get me one number that is odd, that's guaranteed odd. I need a second number that's guaranteed odd. So I think to myself, what else could I do to get that second number? I need 2 more steps to go. So if I'm already doing 2 times x plus 1, and I need 2 more, what would happen if I did 2 times x plus 3? And not leave us a whole lot of space on this page. So if I did 2x plus 3, let's see what happens. So if I had 2 times 0 plus 3, oh look, that makes 3. What if I had 2 times 1 plus 3? Oh look, that makes 5. So that will get me my next consecutive number. So it would be 2 times x plus 3. So this should produce consecutive integers. And now it wants to know what is the sum of those. So I would take this number, this is a whole number there, and I would take this number and I would multiply them together. I did not leave us enough room, so bear with me on my scratch. I'm going to go ahead, since we decided, oh yeah, we don't want to deal with the negatives. We're going to like, Now the problem didn't say positive odd integers, so we technically could deal with the negative. So here we go. So I would have 2x plus 1 plus 2x plus 3. And I'm asking myself, what is their sum, right? So now I'm going to combine like terms. So 2x plus 2x is going to make 4x, and 1 plus 3 is going to make 4. So what this rule is saying, that if I want to find the sum of 2 consecutive integers, odd integers, that I would just plug the values of x into this equation. Not this equation, this expression. And it should work and find out what happens. So I want you guys to test it out. see what happens, plug in different x values, and see if it works. And yeah, alright, that is it. Thank you.